So disconnected graphs are nothing but the graphs which can be split into two graphs. So a graph can be split into and two or more graphs. So let us take an example. So this is the fine example mostly present in each and every textbook. So A, B, C, D, E, F. So these are the two disconnected graphs. So there is no link between the vertices of first graph as well as the vertices of second graph. So these graphs are said to be disconnected graphs. So let us move to the another topic. So let me wind up what we have discussed so far. So we have discussed the graph theory basics about the edges, vertices, adjacency list, cardinality, degree of each vertices, adjacency matrix, and later we have moved into the types of graphs: null graphs, undirected graphs, directed graphs, this simple graph, connected graph, disconnected graphs. So this is all about the graph theory. So let us move to the another topic, that is statistical network properties. That is our fourth topic of our first unit. So fourth topic, that is statistical network properties. So statistical network property means the features that are common between the each and every network. So in this property we will be discussing around 7 to 8 points, where each and every property defines any common features between each and every community. So the statistical network property means that features that are common to network of different types. So we will be dealing with all the features of a network of different types. So let me write all the properties here. I will explain each and every property line wisely. So first property of any network is known as the small world effect. Small world effect is nothing but we will be having a strong bond between each and every community. For example, if you take this as a community, so if there is a problem occurred for any of the vertices, so remaining people will try to help the vertices A. So this is what we call small world effect. So every vertices will be connected, that is every node or a computer will be connected to all the nodes in the world or in the community. So the connections will be, for example, if you buy a book written by me, then the book will be so famous that you will be sharing with your friend, as well as your friend of friend will be sharing to another friend, that friend will be sharing with another friend, that friend will be sharing with another friend. This is what is called small world effect. So we'll be sharing each and every information with the community we have, that is called small world effect. So we would be sharing or communicating with the neighbors. So in small world effect, the bandwidth will be I. When it's coming to the computer networking, in our networking languages, we feel that the bandwidth, the data transfer is huge I. That is bandwidth is huge. So privacy is more. Privacy and security is more. So this is what we call small ball effect. This is one of the property of statistical network properties. So let us move on to the next second property, that is transitive or clustering. Transitive Transitivity or clustering. What is transitivity property in max? Transitivity property is nothing but if A is equal to B, B is equal to C, and C is equal to A. That is what also reflects in the networking. For example, if a system A knows the information and want to pass to the system B, and system B is connected system A and system B, and system B is connected to system C, the information which is shared by A will also be shared to the computer C. This is what we call, and C will all in turn send the packet to the this is what we call transitive property. Whereas considering it is in a community, so if your friend try to give the book that I written, so he will try to give the book to his friend. I have written, and then I gave the book to my friend, and my friend gave to the book to the other one, and last, after his completion of his reading, he have written the book to me. That is what is called transitive property. So coming to the clustering is nothing but combining and grouping all the common interesting features of a people into different communities. For example, if I like the bike juke, if I like the bike juke, and the remaining people who like the bike juke comes under one community, and the person who likes the KTM bike comes under different category or different community. So this is what is called known as clustering. So we'll be looking more into the clustering later in our later lessons. So this is what is clustering known as. So we'll be grouping all the common interest groups into the different communities. So they are different clusterings. So there are two types of clusterings again: overlapping clustering, non-overlapping clustering, as well as the tiled clustering. We'll be discussing all those in our next lectures. So that is what transitive property is. Let us come into the next property, that is degree distribution. So what is degree distribution? So so when considering, so let me take a graph. I will explain it. So A, B, C, D, E, F, G, H. So this is the graph I have drawn. So now let us try to find the degree of each and every node. So if you find the degree of each and every node, so A has 3, so B is 2, C is 2, D is 2, E is 2, F is 3, and G is 1, 2, 3, 4, 5. So G is 5. What is degree distribution? Degree distribution is nothing but the degree as well as the number of vertices it has. For example, the degree distribution is nothing but the number of vertices 3 by total number of edges, total number of vertices, totally 3, 4, 7. So this is known as a degree distribution. So we will discuss degree distribution in our later lessons. Just try to have a glimpse of it. So degree distribution is nothing but whereas in statistical network properties, we will be sharing the information to the most node which have used degrees. For example, this is also known as preferential model. So we will be preferential statistical model. We will be giving a more preference to the vertices which have high degree coefficients. So that is what is known as the degree distribution. So let us coming to the another distribution, that is known as the network resilience. So network resilience is nothing but to provide and maintain an acceptable level of services in the face of faults and challenges. So we will be dealing with the acceptance and maintenance of the information. So we will be getting some information from our neighboring node, and we will be maintain that information will be maintained, as well as will protect that from faults as well as the challenges we will be getting. So actually, if they ping the computer should protect the data without getting any threat. That is what is called network reliances. So I will write the definition. So to provide So remaining the headlines which I am not writing the definitions will be dealing with the will be dealing laterly, so don't worry about that. To provide so coming to the network analysis, to provide and maintain an acceptable level of service in the face of FAULTS false and challenges. So we have to protect the data which we are getting from the different nodes. So for example, if A sends the secret code as well as the packet to the B, B have to make sure that he should not reveal the secret code of A to C. That is what we actually known as data encryption. So we have to maintain that in network reliances. So let's coming to the another statistical network property, that is known as community structure. So what is community structure? Community structure, I have told that clustering is known as the grouping of interest people into single clustering. What is community structure means? Community structure has to maintain its own organization, own organization of different individuals who have similar features. For example, if I say I like Apple, so cluster structure has to make the list of all the persons who likes Apple, as well as the persons who like bananas and different foods. So yeah, it has to make a different clusters, and this cluster has to be formed under another cluster, comes under fruits cluster. FRUITH. So this is what community structure means. We have to maintain an equilibrium community structure. For example, if any of the animal, for example, that is what we call the fittest of the survival. So if any animal dies and the existing species also expires, what will be there? There will be no community of the animal or the species. That is what will be. That is what is known as community structure. For example, if you disturb, for example, if there are water in a jar of glass, if you pour water on the ground, is there any community in the structure? There is no community, but they are flowing out of the community. Sorry, I have repeated more than thrice. So that is what is known as community structure. We have to maintain and build the community structure with the similar features, so that another node or computer will not destruct. So let us move to the another statistical network property, that is known as subgraphs. Subgraphs or motifs. There is nothing to worry about all these. These subgraphs are nothing, but we'll be describing our interest as well as the information that is shared in a statistical manner, that is he likes or not. For example, if he likes, what will be happen, if he don't like, what will be happen. All it defines in the statistical graphs. So it is a subgraphs or morphics. Morphics also known as the graphs within a small range. So that is what we define in subgraphs. So we will be defining all the properties as well as the common interest or the different interest of the people in subgraphs. So we'll be mostly involving in visualization in this part. So let us move to the seventh property, that is densification. So what is densification? Densification is nothing but, for example, if you want to build a community of people who likes Apple, we have to get the each and every individual opinion to form a dense group. So to form a dense group, we have to make some measurements. For example, densification use power law. That is what we will be dealing with. We'll be dealing with it later. So, but try to understand the concept. For example, if I like Apple, so we have to, for example, if there are 10 students, so we have to take the survey of the 10 students who likes Apple. For example, 10 of 7 likes Apple. So we have created 7 dense. So 7 dense people who likes Apple. That is what is called densification. Or if you like to combine all the features into a single community is also known as densification. So that's all about the statistical network property. Let us revise what we have learned so far. So statistical network properties are the features common between different types. So a small world effect. In a small world effect, we will be trying to share communication with our neighbors. Bandwidth size, privacy, security is more. So security is more. That is known as small world effect. We'll be sharing information quickly. That is the small world effect. Transmitting and clustering. If A knows the information and B knows the information, as well as the C knows the information itself. So what is clustering? We'll be dealing with later, but we'll be having some common traits. We'll be classifying into different communities. So degree distribution is the sum of the edges it has by the total number of vertices, that is known as degree distribution. And the network reliance is nothing but will be maintaining the level of service to fall from the changes as well as the challenges as well as the threats. So community structure, we have to maintain and build a certain community structure for us to classify, for us to make some insights from insights using subgraphs and morphics. And densification is nothing but the clustering. So you can call it that densification is nothing but the community structure. Combine of community structure is also known as densification. That is what it is. So now let us move to the another topic, another module, that is known as centrality. That is known as node centrality. Node centrality. So from now onwards, the basic mathematical problem solving will be starting. We'll be requiring our calculator, basic calculator, basic mathematics is required. That's it. So what is node centrality? For every node in a graph, we'll be defining betweenness, closeness, as well as the number of degree it has. We'll be dealing with the properties of the node. We'll be dealing with the properties. So let me define what is centrality. Centrality is nothing but the finding the most important nodes in a network. So that is what is called node centrality. So finding the node which is most important for us. For example, if this is a graph, so in this graph, what is the most important node in this graph? For example, let me label A, B, C, D, E. So what is the important node? Yes, it is the C. If C is not there, the entire graph will be distorted. That are the properties we will be going to look at in node centrality. So what is centrality? So centrality, nothing but it aims to find the most important nodes in a network. In a network, centrality is classified based upon the edges it makes. So centrality, now we have in this example we have seen why did we choose C as the most important node, because C has 1 2 3 4 edges. So C has, based on the edges, we have classified that C is the most important node in this graph. So centrality is often classified based on the edges it makes. That is what is called centrality. So centrality matrix is classified into two types, that is degree based centrality as well as the shortest path based centrality. So centrality is classified into two types. One is degree based centrality, and another one shortest shortest path based centrality. So the shortest path based centrality as well as the degree based centrality. So degree based centrality again classified into two types, that is degree centrality as well as the eigenvector centrality. So degree centrality, eigenvector centrality. And shortest path based centrality is classified into two types: betweenness centrality and closeness centrality. So degree based, so in this module I will be not dealing with the eigenvector centrality because I didn't get any information regarding this eigenvalue centrality. So I will be dealing with the degree centrality, between the centrality and closeness centrality. Okay, so in we'll be dealing eigenvector centrality in offline if I get any information how to solve those eigenvector centrality. So let us move to the degree based centrality. So in degree based centrality we will be dealing with only the degree and the edges it makes. So coming to degree centrality, so we'll be discussing degree centrality now. These are the degree centrality. So degree centrality, so degree centrality is nothing but it is the number of edges connecting to a node. It is the number of edges. So what is the degree? Degree is the number of edges a vertices has. That is what is the definition is. So it is the number of edges connected to a node or vertices, anything by the language you can use. So again degree centrality is classified into two types, that is directed graph centrality and undirected graph centrality. Let me write down. That is not that much useful, but problem solving it is more useful. So degree centrality is again classified into two types: directed graph and undirected graph. So directed graph is again classified into two types: inflow centrality and outflow centrality. So there is not much difference between these two. So once you solve a problem on this topic, so it will be fine, easy for you to get understand. So degree centrality is divided into directed graphs, undirected graph, and directed graph is divided into inflow centrality and outflow centrality. So let us take an example and try to solve the degree centrality. So let me take most graph used in all the textbooks. 5 and it is 6. So this example has been taken by many textbooks. So I am also referring this textbook, referring the problem now. So it is an undirected graph.